So let's continue with the control section and let's get this CPU built. So let's start looking at the load and store instructions. Now when the most significant bit is low, then we know we're in a load or store instruction. And then whenever this bit here is equal to a 0, we'll know we're in a load instruction, and when it's equal to a 1, we know we're in a store instruction. So let's go ahead and first of all we'll look at the store instruction. So we've got it set up here as 0, so we know it's load or store, and we've got the 0, 0, 1, so it's a 1, so we know we're in the store instruction. And we've got these two registers set up here. So the store instruction really says, well, the first 4 bits here are the load or store, so it says store, so we can keep that as a little mnemonic, we'll call that ST. So what we're saying here is ST, and we're going to have our registers, so we're going to have Reg A and then Reg B, so we've got ST space Reg A comma Reg B, so that's our little mnemonic or our little code for this store instruction. And really what it says is, what we want to do is we want to store the contents of register RB to the RAM address that's pointed to by register RA. So really in this instance here then for this example, what we're doing is we're storing the contents of register RB, which in this case is register 2. So we're storing the contents of register 2 in the RAM address which is pointed to by RA, which is the register 3. So really what we can say is that a store instruction really is from register to RAM. So we're taking contents out of the register and we're putting it into the RAM. So let's go and we'll look at the next instruction, which is the load instruction. So here's our instruction code here. We have a 0 at the most significant bit, so it's a load or store instruction. And this bit here is a 0, therefore it's a load instruction. So our little mnemonic here for it is LD for load, and we know our first 4 bits as our instruction, and the next 2 bits are the RA and RB. So it's going to be load RA, RB. So really what this tells us is that we want to load the register RB from the RAM address that's pointed to in RA. Okay, so really what we're saying here then is we want to load up the register R2 from the contents of the RAM address which is pointed to in register R3. So really what we're saying is load is from the RAM into a register. So it's easy to get confused with those two that I've just read out there, but we'll go and we'll build it up in Logisim and it'll become a lot clearer. So if you go into the resources section, you'll see the file called load and store instructions. So if you go and open that up, and then you come down to CPU, double click that. So this is our CPU here. So let me zoom in a bit and we'll have a closer look at what we're doing here. So you can see here that we've got our CPU as usual. In this instance here, again we've got the instruction register that's been disconnected, so we're going to put our own instruction in here, and we're going to start off the store instruction. We've also got access to these 2 registers here as well. So with the store instruction, what we're going to do is we're going to take the contents of this register here, which is register 2, and we're going to store the contents of this register in the memory address in the RAM which is given by the address held in this register. Okay, so I'll say that again. We're just going to take the contents of this register and we're going to put it in the RAM, but the address in the RAM is given in this register here. So let's go ahead and we'll do our store instruction. So we know the most significant bit must be a low, so if that's a low, we know it's a load or store. We know in order to ensure that it's a store instruction that the fourth bit must be a 1. And then what we want to do is we want to store the value of this register here. So this is going to be register 2. So it's register 2, so that's 1, 2. And we want to store this value in this register into the memory address pointed to by this register, which is register 3. So we're going to put in our register 3 there. So this is just our RA for these 2 bits and RB for these 2 bits. So now we'll go ahead and we'll change the values here. So this is the value here we want to move to the register, the RAM. So let's go ahead and we'll just put in all 1s. So we're going to be moving this to an address here. So let's see what address we're going to move it to. Let's move it to address number 15. Okay, so that's 1, 2, 4, 8. Okay, so that's address number 15. So let's go ahead and we'll see this working. So we should be shifting this into address location 15 in the RAM. So we're not going to get into the control section right now, we'll just work our way through it and we'll see it actually operating. So nothing's going to happen until we get to the 12th clock pulse. And then you can see at the 12th clock pulse, we can see this enable here has gone high, and we're going to be taking this number here out onto the RAM, and then next we'll be setting the memory address register. So this is really just telling us what address we want to put this information in the RAM, and we want to put it into that address number 15. So if we just head on to the next clock pulse, and you can see that address has been set. So if we come down into the RAM and have a wee look, you'll be able to see that we've got this address here sitting in this memory address register. And you can also see that the vertical line here has gone high and the horizontal line here has gone high, so we're actually picking out this register here, which is the register number 15. So let's go back up to the top level and we'll finish off the simulation. So again, we'll go back into control section in a minute, so you don't need to bother too much about all the details here. So that's us pointed to that address. So in the next clock pulse round, we're going to grab all our 1s from this register here and we're going to stick it into that address that we've just pointed to. So the next clock pulse here, you can see the RAM has been set. So we've taken this information, which is all the 1s, and we'll put it into the address we pointed to in the RAM. So if we go back down into the RAM here, and we can see here that the set is high on this RAM here and we're pointed to it. So if we go in here and have a look, you'll see that the set's gone high here, and the information here, all 1s, has gone into this register here. So let's have a wee look and see. So you can see all the 1s get into the register there. So they're all sitting at that point in the register. So it's held within that memory location. So let's go back up to the top, and that's pretty much, that's us finished. Okay, so if we continue with the clock here, that's basically us done. We've taken that value here and we've put it into the memory, this memory location here. So that it's only sitting in that memory location, it's not sitting anywhere else. If you went into any other memory location here, you wouldn't find it. You see it's all 0s, and the only memory location that it's set into is the first one in here. If you get into it, you'll see it sitting there. So I've reset the CPU, I've put the registers back to the original values here, and I've put the instruction code in here. So let's go and we'll see it actually working inside the control section. So you see here that There's a couple of sections we're actually taking out because we're not going to use them here. They will be in the final version of the control section, but they're just going to clutter this up. So for example, we're taking out the section here on the opcodes to the ALU and a compare section here as well. So we don't need to bother with that, we'll just leave them out just now. But you see here we've added in this extra little section here, and you can see it's a 3x8 decoder. Now, if we were to, say for example, look at the most significant bit here, if that most significant bit happened to be a 1, then we know it would be an ALU instruction. So if that was a 1, it would mean that this side here would be a 0, and these zeros would all go down to the AND gates. That would mean that these AND gates in effect wouldn't function, so the output for these AND gates wouldn't be determined by the values of the inputs here. But as it stands now, we've actually got a 0 on this point, and we know that the 0 determines it's a load or store instruction. So if that's a 0, that becomes a 1. If that becomes a 1, it means that all of these AND gates are now in play, and the output of these NAND gates will be determined by the input of this 3x8 decoder, and the input from the 3x8 decoder is going to come through and down to these bits here, this one, and this one. And we know we've set this value here as a 1, so you can see that value is a 1, and we know when it's a 1 it's a store instruction. So if this is a 1 here, then a 3x8 decoder will choose the value of 1 here on the decoder. So it means that 1 is high here, and we've got 1 high here, so we're choosing the first AND gate here. Okay, so that's the 0 AND gate. Oh, we could say we're choosing the second AND gate, okay? So the first AND gate is not getting chosen, it's the second AND gate. So that means if this AND gate's getting chosen, we get our output from here into this AND gate and also to this AND gate. Now there's another couple of AND gates as well that we've got in here. There's this one here and we've got this one here. Now these AND gates, these two, they all go off to the stepper, so they're going to go to 0.4 and 0.5 of the stepper. So let's go ahead and we'll have a look and see what these AND gates do and how they work. So the bottom two AND gates here have got high inputs here. Now they've got a high input because we're choosing this particular one, which is the store instruction. Now the top two AND gates, those will go live whenever we choose the first AND gate here, which will happen whenever we do the load instruction, which we'll see just in a minute. So you can see here these two bottom AND gates, we're in step 4 at the moment. So this one and this one is going live. Now one thing to notice, I've had to add in an extra little section here. Now by rights these 2 points would be connected together and then they would go up here into the same point, this line and this line. But whenever we connect two AND gates together like that, the outputs of them, Logisim won't allow us to do that. So what I had to do was split them up and put them through an OR gate, and then we've just put the two separate lines here. Okay, so it's just really a fudge in order to get this thing to work in Logisim, because Logisim won't allow us to connect the output of two AND gates together. So you can see here then what's going to happen at point 4 is that the RAM enable is going to be, Reg A is going to be enabled and the memory address register is going to be set. So let's go down to Reg A. So there's our Reg A there, and that Reg A has been enabled. So when we come down here, that means that we're on these 4 here, these have all gone live, and these 4 here are going to be chosen by Reg A, and that's going to come from these 2 bits here, this bit and this bit, which is going to be a value of 1 and 1, which is going to choose this one here, which is going to choose register 3. So really what we're doing is we're taking the contents of register 3 and then we're going to be putting it into the memory address register whenever the clock comes along. So let's go up to the top level and we'll see that happened. So you can see we've enabled register 3, we've put this value here onto the bus, and now when we go to the next clock pulse, which is the set will come high, and we'll have put this value into the memory address register. So remember, all this just contains the address of the RAM that we're interested in. So we've put that address onto the bus, and then we put it into the memory address register. So if we come down into the RAM, you can see here that the vertical line has gone live here, and the horizontal line has gone live here. So we're choosing this memory address location, okay, which is memory address location 15. So let's go back up to the top level and we'll go on to point 5, okay. So what we want to do is we want to pulse the clock until we get to stage 5 of the control section. So there's the enable going low, so whenever the enable goes high, that'll be us on stage 5. So let's go into here and have a little look at it. Okay, so now we're on stage 5 of the stepper, and you can see that this line here now has gone high. So whenever this line here has gone high, we're saying reg B is enabled and the RAM is set. So if you come down here, we've got reg B enable. So reg B enable means that these 4 here come into play, and they're controlled by this reg B decoder, which is controlled by these 2 points here, the 0 and 1. Okay, so that's going to choose our register 2. So register 2 is enabled and onto the bus. So the contents register 2 go onto the bus, and then they're going to get into the RAM. So the RAM's going to be set on the next clock pulse. So there's the next clock pulse come along there. So the RAM is going to be set. So if I zoom out a bit, so the value here is going to go into the RAM. Okay, so what we've done is we've enabled the value here onto the bus, which is all ones, and then we're going to put that value into the RAM set, and it'll begin to the memory location given by this here. Okay, so if I was to drop into, we'll just go over the next clock pulse to set it going low now. So if I was to get in here and have a look, we could see here that the vertical is going high, the horizontal is going high. We've chosen this particular RAM location. When we get into that RAM location and have a look, you'll see that inside it, the value of 1 has gone in on the, it's been saved into that RAM location. Okay, so even whenever all the rest of the values go back to 0 there, you can see that this RAM location, it still holds a value of 1. Okay, so the input's gone to 0, but it's still retained that value there which we've stored in it. So that really is our store instruction. We'll go ahead now and we'll look at the load instruction. So now let's look at the load instruction. Now the previous store instruction, it took the contents here and it placed it in the memory address which was pointed to with the contents from here. Now what we're going to do is we're going to take the contents from the RAM which is pointed to from here, and we're going to put it back in to the register here. Okay, so it's just the opposite process. We're going to take it out of the RAM and put it into the register. So in order to do that, we have to set up our instruction address, instruction code here. So that instruction code for our load is going to be all zeros. So we can put that all zeros. Now what we can do is we can check out where we are here. So we're at point somewhere along here. So let's have a look and we'll just continue this along until the bus 1 goes high, and we know we're back to the beginning. So that's a bus 1 going high. So let's put in our 12 clock pulses. So that's our 12 clock pulses here. So whenever we come down into the actual control unit here, you'll see now that in this control unit, the value here is going to 0. So this is going to 0. So in this 3x8 decoder, we've now chosen 0 as opposed to 1. And by choosing the 0, it means that this AND gate here has now gone high. So if this AND gate here is gone high, then we're choosing this output here, and also it will be this output here. So we can see we're in step 4 here. That's gone high, that's gone high. We have our output gone high here, and again we've got these here, so it's going to be Reg A enable and memory address register set. So we come down here and we've got Reg A enabled. So Reg A enabled here, and it's choosing R3. Okay, so we're taking the contents of R3 and we're going to put them on into the memory address register. So let's go and we'll have a look at this at the top level. So we can see here that this register here has been enabled. So we've taken the address that we're looking for, we've put it onto the bus here. Now in the next clock pulse the set will go high, so we'll just, that's the next clock pulse here. So the memory address register has been set, so now we're pointing to memory location number 15 within the RAM. So let's move on to the next stepper section. Okay, so we'll wait till enable goes low and then enable go high again. So that enable going high, we can zoom in and we can see here that we're now in stepper position number 5. In stepper position number 5, we now have this line selected here. So this line selected, it's going to be RAM enable and then Reg B set. So let's look at the RAM enabled. So we'll go to the top level. And we can see here that the RAM has been enabled. So we've taken the contents of that RAM address here, 15, we've put it onto the bus. Now the next thing we're going to do is going to set it in R2. So we click on the next clock pulse along. That's the set here, and you can see the set's gone high. So in effect we're taking that value that's on the bus and put it back in here, and it's all ones that we're putting back in. So you can see the process that we've worked through here with the store and the load. When we did the store, we took the contents of this memory location and we put it into the RAM, and the point we put it in the RAM, the address of the RAM was contained in here. And when we do the load, we do a similar thing. We have the address of the RAM here, but instead of going this way into the RAM, we're going from the RAM back out and into the memory location. So that's all there is for the load and store instructions. So thank you for listening to the video. I'll get you on the next video. Goodbye.